Alrighty, we are a minute early for our live review today. That should say hosted by me, Brandon Wu. Hello, good to see ya. Wearing my Fiveable shirt today. We'll get started at around 4:01 Eastern, 3 p.m., 3:01 Central, 1:01 Pacific. Super excited to see y'all here. As people trickle in, if you haven't already, go ahead and fill out the poll in the poll section. I just want to gauge if all of you here are here for Calculus AB, or if I have a few people from BC, because that will kind of decide how today's FRQ review goes. So I'm super excited. So go ahead and fill out the poll if you are in AB or in BC. Ooh, we got a 3-2 AB BC. In the meantime, I guess I'll get started with my presenting stuff. So first of all, go follow Fiveable on all of their social media. For instance, we made a TikTok account a few weeks ago, and we really would love to see y'all support us. But also check out our Twitter, Instagram, and YouTube. We send out reminders. We talk about new products from Fiveable, like our podcast, Homeroom by Fiveable, which you can find on Spotify. Great podcast to listen to. Also, we have a lot of content coming up. And for those of you who are answering that you're in AB or BC in the chat, make sure you're also filling out your answer in the poll section. On mobile, it should be like the third tab, the second or third tab where you're able to vote in a poll. And on desktop, in the little Fiveable screen at the bottom tab here, next to where it says ask a question, there's also a tab that says poll. So go ahead and fill out if you're in AB or BC. Speaking of streams, we have so many live reviews coming up for all of the different AP subjects, all 14 of them. We have English language, we have stats, English literature, current events today, calculus later this evening at 9 p.m. Eastern. All of these times are in Eastern. We have social sciences on Tuesday, science on Wednesday, and history on Thursday. For those of you who are joining in, wow, looks like we have a nice audience today. Be sure to fill out if you're an AB or BC in the poll section. So yeah, basically in terms of upcoming live reviews, we're covering L'Hôpital's rule this evening, at 9 p.m. Eastern, and that's with Megan Dwyer, one of our great calculus teachers. Next week, we'll have our FRQ review at 4 p.m. Eastern. We'll have justifying and explaining your answers at 9 p.m. We have the 2018 FRQ review and more streams. So basically how calculus will work is that we'll have our live reviews, we'll have live FRQ reviews, at 4 p.m. Eastern on Mondays. And then we'll have the actual lecture style where we're teaching content for the AP exam at 9 p.m. Eastern time. Yeah, so in terms of the College Board update, Calculus AB and BC, if I remember correctly, is scheduled on May 12th. At 2 p.m. Eastern. And if for some reason you have to make it up, it's at June 1st at 4 p.m. Eastern. You basically have 45 minutes to take the exam. It's 2 free response questions if your teachers haven't already told you. 25 minutes to do the first FRQ, 5 minutes to upload it, 15 minutes to do the second FRQ, 5 minutes to upload, and you can also handwrite and take a picture according to College Board. Note that it's a 60% to 40% weight in terms of the FRQs, and also they are technically open book, open note exams, but that does not mean that you can collaborate with people. For instance, if College Board detects that you use some of the similar wording or answer, you basically plagiarize from somewhere, they will notify every college that you've sent an SAT score or an AP score to. They will not let you take a College Board exam in the future. And copying responses from notes or resources, also, you just won't have time for it. So it's always good to learn yourself and really kind of learn the content so you don't have to be flipping back and forth between your notes because you're going to lose time. In terms of what will be on the exam for Calculus AB, units 1 through 7 are going to be covered. You can submit unsimplified numeric answers that you should still be solving integrals and stuff as a clarification, but it means that, for instance, you can leave things in point slope form. So if you look at unit 8 right there, everything on my screen for Calculus AB, those 2 pictures right there, those are cut from the exam. So volumes with cross sections, volume with disk method, finding area between curves, position, velocity, acceleration, average value, all gone. And in terms of the FRQs, they're not going to announce what they specifically cover, but just assume that it's going to be like the usual FRQs and that it's going to be multiple parts spanning multiple units. So that should be pretty exciting. In terms of my BC fellows out there, and yeah, position, velocity, acceleration is usually important. Kung Flu Panda, Mike, but they got it. So it is what it is. Okay, cool. So for my BC people, on your exam, all of Unit 9 is gone. So parametric, polar, vector valued functions are all gone. And about half of Unit 10 is gone. So that means like convergent and divergent infinite series, the nth term series, integral, comparison, tests, or the integral test. I can't even think right now. Absolute and conditional convergence, the Lagrange error bound, and Taylor-Maclaurin series. Although they did include units 1 through 8, so everything on this screen is going to be on the BC exam: cross sections, average value, position, velocity, acceleration. In addition to the geometric, harmonic, and P series. Geometric series, harmonic series, P series, the alternating series test, ratio test, Taylor polynomial approximations of functions. Those are going to be on the BC exam. Just wanted to keep you all up to date. So in terms of what we are going to be doing today, we're actually going to do a little bit of BC for my BC friends out there, because I saw last week, I think Natalie said, could you do a BC question? And I was like, sure, why not? So we're going to start off with some Euler's method. It's not Euler's method, fun fact. We'll go into volume by cross sections, and we'll end with Taylor polynomial approximations. And then in terms of AB, we'll be doing an in and out function. We'll be doing like a graph and extrema question, or derivatives and table, approximations, tangent lines, and separation of variables. So I am going to ask the students in AB and BC, because you're all going to see some sort, like all of you are going to see some content in common. So would you rather, just answer in the chat, would you rather do a question where there's a graph and you have to identify extrema and justify, or would you rather do a question where there's like a table of derivatives? Like here's the first derivative, here's the second derivative. Okay, I see a table, graph, table, table. Okay, either. I'm gonna keep, because I think there's more than 10 people here. So let's see what the consent. And also, for those of you who weren't here last week, I did a review of a graph and extrema, so you can check last week if you need to review with that stuff. So, I see that some of y'all didn't get okay, table it is. Thank you for letting me know. So we're going to start off with BC. And for those AB children out there, y'all are probably the same age as me or older. Actually, you can't be older. I'm a senior. We're basically going to spend like 15 minutes or so on BC and then 30 minutes on AB. So I'm going to switch screens really quickly. You can enjoy my beautiful face. Let's go here to bit paper. Okay. Whoa. Let me click focus here. Alrighty, so we're going to start off with BC, and I'm actually going to paste the FRQs. Sorry about that. So the first link that I'm sending is the BC one. The second link is the AB one. You don't need to necessarily do it. Like, you don't need to click through these links if you want to. Will differential equations be on the AB exam? I do believe so. Yes, like separation of variables will be on the exam, that kind of stuff. I think that's in Unit 7. So yes. Or Unit 8? Yeah, I'm not sure. I'm pretty sure it is, because you still have to know how to separate variables for the exam at least. Yeah, Unit 7. Okay, cool. So for all of you BC children out there, you know that in the AB curriculum, it's our Unit 1 through 6, plus the stuff like integration by parts, linear partial, is it integration by partial fractions, and this fantastic method called Euler's method, or Euler's method, however you pronounce it. So basically, in order to do this kind of stuff, we just got to memorize. Either you can do one of two things. One, you can learn the technical method, like you can learn it like an equation, sort of how I've explained it with like a different concept, or you can do like a table. So I'm going to first show you the table method, and then we'll get into the algebraic method per se. I'm actually going to answer the two questions here first. Are optimization problems heavy on the FRQ exam? We don't know. It might show up on one part of one FRQ or both FRQs. It just depends, because they cut multiple choice where we used to see some optimization in terms of like Bob can build 150 yards of fence, that kind of stuff. We should still expect in and out in problems. I don't know, Mr. Panda. I'm going to call you that. But there's a possibility they bring it back. I still think that the concepts on an in and out question are relevant to AB and BC. Jack asks, will volume be on the AB exam? No. Volume by cross sections, disk, washer method, all cut. So only the BC people have to deal with that. All right, let's start off with this differential equation and what we're going to be doing. So it says here that let y equals h of x be the particular solution to the given differential equation with h of 0 equals 2. And it says to use Euler's method starting at x equals 0 with two steps of equal size to approximate h of 1. So first we need to identify what those two steps of equal size are. And in this case, those steps are just going to be 0 to 1/2 to 1. That is our equal steps. And in terms of Euler's method, the way that I like to do it is I like to make a little quick chart. So my chart looks something like this. I have x comma y. I have dy dx equals whatever they give me. So in this case, it's x squared minus 1/2 y. And then I have delta x, which is the change in x, and then I have the change in y, which is just dy dx times delta x. And finally, I basically write x plus delta x, y plus delta y. This is the way that like Khan Academy teaches it too. It's the way that's most effective for me. So we start off with what they give us, which is 0, 2. And so then we just plug and chug into dy dx. So x squared is 0 squared minus 1/2 times y, which is 2. So that ultimately gives us a dy dx of -1. We know that our delta x is 1/2 because we're moving half steps up. And then we know that our delta y is just -1/2 because it's dy dx, this, times delta x. So then ultimately we add x plus delta x, y plus delta y. We get our new point is positive 1/2, 3/2, which is just 2 minus 2 subtracting 2 minus 1/2. So then we move on to the next part. So we have 1/2, 3/2. So then we plug this into dy dx. We get 1/2 squared minus 1/2 times 3/2. And we ultimately get, if I do this in my head, that's 1/4 minus 3/4. And that makes -1/2. So then we know that our delta x is still 1/2. We multiply, we get -1/4. And ultimately, we get that whenever we add 1/2 plus 1/2, we get 1. Whenever we add 3/2 plus -1/4, we get 5/4. So that is the way that I learned Euler's method. And so that would give me that h of 1 is equal to 1, 5/4. That's the way that I learned it. And so how did I get 1/2, 3/2? Basically, I added x plus delta x, y plus delta y. So that's Euler's method, at least the way that I've done it. The other way you can do this, and I'm going to quickly clear the board, is you can do it in kind of algebraically. So you can take, I didn't mean to clear the whole thing, but you can do like h of 1/2 because they gave us 0, 2, if I remember correctly. Yeah, 0, 2. You can do h of 1/2 is equal to h of 0 plus h prime of 0 times 1/2. So it's the same kind of concept in that you're starting off with the x, you're plugging in the 0 into it, and then that eventually gets you 2 plus -1/2 equals 3/2. So it's kind of the same thing. And then you plug it in again and you get 5/4. No, Euler's method will not be on the AP exam. All right, let's move on to the next part here. We're going to talk about the volume of a funnel with cross sections. Remember, this is BC only, so you don't need to worry about this if you are in AB. So in terms of this question, volume of this, we have this funnel here, which I did not put the drawing in, but I can sketch it out. It looks kind of like this. We know that this is the radius. And we know that this is the height. It's crooked, I know, but we'll get through it. So essentially all we need to do here to find the volume is we need to do a lovely, like just remembering how to find the volume in general. So we know that for volume, it has to do with pi r squared h, right? In terms of like cylinders and circles and things like that. So we're going to be doing something along those lines here. So first, I'm going to look at what it's asking for. We know that it's going from 0 to 10, and we know that we're using circular cross sections. We know that the radius of the funnel is r equals 1 over 20, 3 plus h squared. So what I would do in this instance is what I would basically find it. I would take the integral, and I would go from 0 to 10 as given in the question. I would put pi actually on the outside because the integral of pi is like it. You would move pi on the outside, as we know from our integration rules. And then we would basically take this radius here, which is 1 over 20 times 3 plus h squared. I would then make this in terms of, I would be finding the integral in terms of with respect to height. That's what you call it, dh. And then from here, once you square everything out, which is just your usual algebra, you get pi from the integral of 0 to 10 of, pi over 400, which is just 120 squared. Pi over 400, 0 to 10 of 9 plus 6h squared plus h to the 4th of dh. And so then, if I can scroll down, I don't know if I can. Looks like I won't. So then from here, we would basically get something along the lines from our usual integration. This would be h to the 5th power over 5 plus 2h cubed plus 9h. And that's multiplied by pi over 400. And that's from 10 to 0, or 0 to 10. And ultimately, once you add it all out and plug in 10 and 0, you get 2209 pi over 40 inches cubed. Very sort of confusing in terms of volume by cross sections, but if any of y'all have questions, let me know, especially those like 3 or 4 BC people who are out there. If not, I'll keep going. All right, I think we're good. Cool. Let's go over to this question. So it's basically saying that the funnel contains liquid that's draining from the bottom. At the instant when the height of the liquid is h equals 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. This instant, what is the rate of change of the height of the liquid with respect to time? So this is related rates. And so this actually might fall under AB if I'm correct, because it's not. Okay. I might be silly then. So in terms of this question, it's just asking how, basically with one respect to what, how is this going to work? So basically what I think of it as is, I know it's dr over dt. That is basically the rate at which the radius is draining. So this is the radius rate. So radius rate is dr dt, and that is equal to, so basically I'm taking this r equals 1 over 20, 3 plus h squared, and I'm finding the derivative with respect to time. So I'm finding, basically I'm doing d of dt of r equals 1 over 20, 3 plus h squared. So once I find the derivative with respect to time, I'll get something like dr dt equals 1 over 20 times 2h through our usual fun stuff. And then this is chain rule, h squared with respect to time. So dh dt of h squared would get you 2h times dh over dt. Yeah, I think it can be AB. Yeah, I was like, I thought I was going crazy. So this does apply to AB people out there. So I'm actually going, does everyone sort of get where I'm going right now? I know I'm a little bit out of it, but do y'all sort of get the process? Okay, then I'll start over. So let's start from the beginning. So they gave us this, they tell us that the radius is given by r equals 1 over 20 of 3 plus h squared. So we know that r, the radius, is 1 over 23 plus h squared. So what is it asking for us to find? What is the question asking? Just answer in the chat. What are we looking for? dH dt. Yeah, so we're finding basically the change of height of the liquid with respect to time. So we don't know dH dt. Whoops. What do we know? What have they given us, and what is given? What is given and what is the numeric value? H equals 3, okay. And what else? dr dt equals 1 over 5. Good job. So we have our lovely, lovely values of, we're looking for dH dt. We know h equals 3. We know dr dt equals 1 over 5. So basically what we're going to do is we're going to try and put this r function in term. We need to get to dH dt somehow. And the way we do that is by finding the derivative with respect to time of this function. So what is d of dt of r? What does that get us? D of dt, the derivative of r with respect to time. Yeah, dr over dt. Yep. And then when we take the derivative with respect to time of this part, what do we end up getting? What does the 10 mean at the beginning? What do you mean? I don't see it 10. I don't think so. Oh, 0 less than h less than 10. That's just saying that, yeah, it's just a restriction in terms of height. In this instance, that doesn't matter because we're not touching it right now. Okay, so someone answered 1 over 10 times h plus 3. That is close, but it's not quite it, Kung Flu Panda, Mr. Panda. And that's because if we think about it like this 1 over 20 would be like on the outside. So we don't touch the 1 over 20, and we can treat this 3 plus h squared almost like 3. We can kind of treat it like a chain rule, and that it's like h squared. So I see 1 over 10, 3 plus h times dh over dt. Okay. Okay. Well, let's think about it like this. Let's take the derivative of, we'll put 1 over 20 on the outside of 3 plus h squared. So this, what rule do we use for 3 plus h squared? What would that be? Oh, I see how you're all doing, chain rule. So then you put 1/10 on the outside. Yeah. Sorry, I was like going crazy there. So after we do the chain rule, and y'all get 1 over 10 times 3 plus h of dh dt. Oops. Let's put that in 1 over 10 of, oh, the h, I'm so sorry. The h is on the inside. That's why I was going crazy too. I was like, I don't think we use chain rule there. So because h squared is on the inside, then what would we do instead? Yeah, sorry. That's on me for me drawing my squares on the wrong place. By the way, this is a good lesson for all of you taking the AP exam. Like putting a square on the outside versus on the inside of a parenthesis can really change the answer of a question, because 3 plus h squared all parentheses would mean what we end up getting is, okay, let's draw this again. dr dt is equal to 1 over 20 of, whoops. Then we would move this 1 over 20 to the outside there. And so not quite. It's not 1 over 10h. And the reason it's not 1 over 10h is because all we're doing is we're finding the derivative of h squared with respect to time. So if we're finding the derivative with respect to h squared, it's just going to be 2h dh dt because of the chain. Because of the chain rule, yeah, because the 2 moves over here, and then we find the derivative of h, which is dh dt. So the 1 over 20, just stays. It's as in like when we did this earlier and we moved the pi to the beginning. So the 1 over 20, we don't touch it because the 3 we can basically ignore because the derivative of 3 is 0. So 1 over 20 is multiplying to the entire thing. So it's as if we were doing like the derivative of 1 over 20 times h squared. So we would move this 1 over 20 to the left side, we would get 1 over 20th of the derivative with respect to time of h squared. And we'd get 2h dh dt times 1/20th. So then from there, we would proceed. We would get dr dt equals 1 over 20 equals 2h times dh dt. And so from there, am I doing this wrong? Am I going crazy? Then we'd plug in the h. Why can't you distribute? Good question. So, okay, I guess you can take this two separate ways. Yeah, I'm going crazy. 1 over 10 of dh dt, yeah. 1/10 h, yeah, 1/10 times 2h. 1/20th, 2 over 20th is 1 over 10. Thank you for correcting me there. So then we get 1 over 10 h of dh dt, yep. And then we plug in our numbers, h equals 3 and dr dt equals 1 over 5. So then after we plug in 3 and 1 over 5, we get 1 over 5 equals 3/10 of dh dt. Is everyone kind of clear where we're at now? Sorry about the whole mix up with 2 over 20. Yeah. So now that we have 1 over 5 equals 3 over 10 times dh dt, how do we find dh dt? What do we do? Or I guess what's the answer since we have all the numbers in front of us? Algebra, yep. And so dh dt is equal to 2/3. And in this case, technically the rate is negative. So this should be decreasing at a rate of 1/5 inch per second. So it would be negative 2/3. And in this instance, I would always use our units. So negative 2/3 inch per second is what we would want to use here. All right. Does anyone have any questions? Yeah, because height is getting smaller. Does anyone need me to clarify anything else or do more before we move, I think, into like our core AB stuff? Sorry, that took a little longer than I expected. So you just add the negative. Yeah, well, the dr dt was meant to be negative 1 over 5, Akshita. That's an oversight on my part. The radius of the surface of the liquid is decreasing at a rate of 1/5. So then whenever you do the algebra, negative 1/5. Jorge or George, these questions I linked way above, but I'm going to paste them down here. So there you go. Oops, I already sent this message. That's rude. Thanks. So we just covered a little bit of the BC stuff, and now we're moving into calculus AB. Could you leave the answer in the step before since it's all numbers? Yeah, I think so. You can just call it negative 2/3. And yeah, algebraically, negative 1/5 divided by 3/10 equals negative 2/3. All right, let's move into some AB stuff. Oh, sorry, one last BC concept, which is Taylor series. So we're going to talk quickly about alternating series and basically approximating a series using some of the first of those terms. So for the BC people out there, does anyone remember how like our fun Maclaurin-Taylor series, how do we write it out? If you can type it out. If not, that's okay. Or how do we know what to plug into where? General, broad question. Hard to type. Okay, well, what I would do is I would basically look at what we have to, sorry, this is an alternating series. So what they give you here is that fn of 1 is equal to negative 1 to the n power of n minus 1 factorial over 2 to the n, right? So what we're basically going to do is we're going to start off with what they give us, which is the Taylor series for f about x equals 1 can be used to represent f of 1.2 as an alternating series. So use the first 3 non-zero terms of the alternating series to approximate f of 1.2. So yeah, the nth derivative of x minus a divided by n factorial. So what, for the BC people out there, as a review, what's the first thing we need to do with this Taylor series? What would we start off doing? Or what would you do if you saw this on your exam? Find the values. Yeah. I'm going to wait for now. Okay, same. Great. So then what I would do from here is I would write out that f of 1.2. And so remember that technically we are approximating. So make sure you're putting the approximation sign rather than the equal sign. And so then I would write, we start off with 1. We subtract it by 1/2 times 0.2. And that comes from our lovely alternating series here. And so then from there, oh, that looks like 0.7, 0.2. And then we would add it to 1/8 cubed, or sorry, that's 1/2 cubed, 1/8 times 0.2 squared. So this is our usual our Maclaurin-Taylor series, as you remember, that we increase in degree multiple times. And so then that equals 1 minus 0.1 plus 0.005, which equals 0.905. And so that's how we get our ultimate answer. Alrighty. Cool. So I guess we'll move into in and out. All right, so for those of you here in AB, what does a left Riemann sum look like? I'm just going to sketch some stuff. And so this is sort of review from last week. So that's a terrible curve. So is left Riemann sum look like this? That's like a midpoint sum. Or does it look like this? So top or bottom, which one does it look like? The second one, bottom. Yeah, so this is our classic left Riemann sum. So what I like to do for these kinds of questions is just to make sure that I don't accidentally do like a right Riemann sum, I like to sketch it out quickly, and then I do the actual algebra for part B. So what I would do is this is 0, this is 1340, this is 1190, this is 950, or that's way too fast. This is 1340, this is 1190, 950, 740, 700. So it looks like this. So then our left Riemann sum would start here, and it would be an over approximation, over estimate, as you can see here. So go down like that. So that's our left Riemann sum using that far left point. And so then what I would do from there is I would calculate the actual like area values. So for part B, for number 1, for an in and out, I would start off. So what do we need to use, an integral or a derivative for Riemann sums? This one you shouldn't mess up. Integral. And what integral would we specifically be using? The integral from what to what? Read B very carefully. From 0 to 8. Yeah, great job. So because we're using the integral from 0 to 8, remember that we need to write something along the lines of the total amount of water is given by the integral from 0 to 8 of r of t dt. So total amount water removed technically. That's equal to the integral of 0 to 8 r of t dt. And so then our Riemann sum would just use those left values. So we would do our length here, which is 1, times our height here, technically, which is 1340. So we have 1340 times 1. And then we would add it to 1190 times 2, et cetera, et cetera. And then eventually we would get 8,050 liters. So then notice, it doesn't say just to find the Riemann sum. It says that you also need to answer if it's an overestimate or an underestimate and to give an answer. So the total would be for all the water, not the amount removed. Yeah, and so you don't add the initial amount. Thanks for answering in the chat, y'all. Appreciate y'all a lot. Yeah, it's only asking us to estimate the total amount of water removed. So it's just us taking the function of r of t and finding the integral. Yeah, so it's an overestimate, but why is it an overestimate? So this kind of comes into handy for next week's live stream. next Monday at 9 p.m. Eastern. Can you use concavity as an explanation? Technically, yes, but there's a much easier yes. And Natalie gave a really good answer there, that the function is decreasing and you're using a left Riemann sum. And so in that instance, I think that would just be enough to get credit on the AP exam, to say that you're using a left Riemann sum and it's a decreasing function. That will justify as to why it's an over-under estimate. Okay, now let's do part C. So it says use your answer from part B to find an estimate of the total amount of water in the tank to the nearest liter. So how do what's our function for total amount of water? What would that look like? Does anyone know? You're still confused about B? Okay, Akshita. So what it's asking for is a left Riemann sum with the 4 subintervals indicated by the table to estimate the total amount of water removed. So we're taking the total amount of water removed function. Yep. And I see someone already answered for part C. I'm just going to quickly go over part B. All we're doing is we're taking R of t, which is a rate function, and we're finding the amount of water, which means we have to find the integral. And so we're finding the integral from 0 to 8 by using Riemann sums, because there's a chart here. So because it's a left Riemann sum, we always use the leftmost like height, I would say. So it would be 1340 here times 1. And then we would do 1190 times 1. And then we would just, or 1190, sorry, times 2, because it goes from 1 to 3. That's a 2 difference. And then we would do 950 times 3, 740 times 2. And so then you would get 8,050 liters. And so that's the amount of water that's removed. And then it says, is it an over-under estimate? It's an overestimate because it's a left Riemann sum and a decreasing function. So for part C, yeah, I see a lot of good answers here. We see it's just added minus removed. Yeah, it's added minus removed, but just remember you also have to include that initial function. So yeah, it is 50,000. And in this instance, it would be 50,000 liters of water plus the amount of water that's added, which is the integral from 0 to 8 of w of t dt. And that's subtracted by technically the integral of r of t, but we already calculated that that is 8,050. And so then to find the integral from 0 to 8 of w of t, I think this question on the AP exam, you'd get a calculator. So for those of you who have a calculator right in front of you, can you tell me what the integral from 0 to 8 is using this function right here of 2000 e to the negative t squared all over 20? Can you go over C again? Yeah, I will. So yeah. Okay, so it's asking for total amount of water, and total amount of water is always the amount of water that's added minus the amount of water that's removed. And obviously we're finding the integral of the rate to find the amount of water that's coming in and the number of water that's coming out. So the first thing we just have to understand is that we have to integrate the w of t function, which is the in function, and we have to integrate the out function, which is r of t. And so we do in minus out, the integral of in minus the integral of out. And also we have to keep in mind that there is an initial condition, that at the start, it's not at 0 liters, it's at 50,000 liters, Anika. So we start at 50,000 liters, we add some water, and we subtract some water. So that's what we're doing today. So we have 50,000 plus the from the integral from 0 to 8 of w of t dt minus 8,050. Okay. Perla, you said you keep getting 8,110. That might be from R of t. And remember, we're using the overestimate of the Riemann sum from part B of R of t in the yeah. So make sure you use W of t in this instance. And yeah, you would get 12,589 if you add the 7,589 of the integral plus, and that should say, shouldn't it be 50,000 plus 7,830? Okay, so that would, what's the final answer that y'all end up getting? I guess I'll just ask that because I think a lot of y'all are at certain parts of the mathematics process. Okay, so Perla got 49,726. Akshita got a negative number. What else? Okay. Just going to wait because I don't want to spoil. Kung Flu got 45,49. I'm just asking for the final answer here. Make sure you're including 50,000. And if you can't see that clear enough, I don't know if I can zoom or not. Nope, doesn't look like it. I'll type it out here in the chat. It's 2,000 times e to the negative t squared all over t squared over 20. Sorry, so t squared over 20. And okay, I see a few of you got 49,786, and that is the correct answer. So what you should have gotten from your calculator is 50,000 plus the integral of 0 to 8 of w of t dt. That's around 7836 or so, 7836.2-ish. And so then you add 50,000, subtract from 8050, and you get 49,786. So I think here, this is just a calculator question. So what you would do is the 8050 part of the integral, that's the out function. And we calculated the 8050 right over here from part B. So what you plug into your calculator should be 50,000 plus I have a T-Inspire, but for those of you who use like other TI calculators, it should be in the realm of menu, calculus, integral, and then it'd be the integral from 0 to 8 of 2,000 times e to the negative t squared over divided by 20 with respect to dt. And then we would subtract. Yeah, that works too. 50,000 minus 8050 plus the integral. And that should get you 49,786.2. I don't think you can see that because it's flipped. But yeah, what Perla there answered pretty well. Yeah, the integral of w of t from 0 to 8, basically 50,000 minus 8050 plus the integral. That works. So that should get you a final answer, as I said earlier, of 49,786. And worst comes to worst, y'all, on the real AP exam, I think you can even use like Desmos, which should get you an answer. Although if you have a calculator, that's probably preferred. All right, I don't want to spend too long on this in and out question, so I'm going to keep it moving. So let's go to 1D here for time 0 less than or equal to t less than or equal to 8. Oh, I got a question here. Why isn't the 8050 part of the integral? Because remember, it's the integral of w of t minus the integral of r of t. Yeah, and we already, whoa, that's an ugly r. The integral of r of t, and we already know the integral of r of t, that's 8050. So we plug that in place of the integral of r of t. Caitlin, I'm not too sure about that. I thought you could. That's what I heard, that you can use online calculators, but talk to your AP teachers just to make sure, because they might have gotten new information from like coordinators and stuff. Yeah. Okay. So let's look at part D here. It asks, is there a time of t when the rate at which water is pumped into the tank is the same as the rate at which water is removed from the tank? So what would we need to find, broadly speaking? Yeah, and also Texas Instruments has given out has like online software for free calculators. When W of t is equal to R of t, and how else could we write that? W of t is equal to R of t. There's another way we can do this. Anyone know? Yes, the difference equals 0. Great job. And that's something you'll use in statistics if you're going to take that class. So W of t minus R of t is equal to 0. So we basically need to find when it equals 0. So insofar that is true, how is there a time t when the rate at which water is pumped into the tank is the same as the rate at which, and yes, sorry, this is an IVT question. And so good job, Perla. Thank you for noticing that. In terms of the IVT, what do we need to prove in order for IVT to be true? Needs to be continuous. Good job. And we need to show something else for the intermediate value theorem, find endpoints. So what I would do if I were taking this, I would write something along the, basically I would have to prove that W of 0 minus R of 0 is, basically it goes from greater than 0 to less than 0. That's the only way that I can show that at some point they equal each other. So then I would write something along the lines of W of 0 minus R of 0 is greater than 0, and then W of 8 minus R of 8 is less than 0. So that means that at that point, there has to be a point where they equal 0. So then you can say something like, I'm just going to type this because I'm a terrible, terrible, terrible writer. Differentiables for MVT, yes. How would you identify if it's a continuous function? I thought it was, oh, I guess it's not given. So technically you can use a limit, but I think in this case, just saying that it's continuous would be enough on the exam. So you can say like the intermediate value theorem. I'm about to paste it in. From 0 Okay, so then I think you can see that there. Yeah. So if it's differentiable, I think you can assume that it's continuous. And then, yeah, you can look at, thank you, Kung Fu, for that. And so then you can say something like the IVT guarantees at least, misspelled, one time t from 0 less than t less than 8, for which W of t minus R of t equals 0. And at this value of t, the rate at which water is pumped into the tank is the same at the rate at which water is removed from the tank. So you identify it as an intermediate value theorem question whenever it's information that you can't necessarily find, and also when you don't have to do differentiation or integration. So in this case, it's asking when the rates are equal. And so the only way that we can theoretically find when the rates are equal is by using something like a theorem to justify. I hope that makes sense, because they don't give us R of t and all we get is a chart. So we can't actually find the value. So we can't actually find the value. We'd look at something like a theorem, intermediate mean value theorem. Alrighty, we're nearing 47 minutes, so I'm gonna skip on over to, I think we're doing the derivative question here. Okay, so number 6. And I think actually we're going to end today on this question. So we're gonna skip that. We're gonna skip separating variables because we just don't have time. So in terms of this question, let's look at what it tells you. So it says that the functions f and g have continuous second derivatives. And it says that the table above gives values of the functions and the derivatives at selected values of x. So first it says, let k of x is equal to f of g of x, and write an equation for the line tangent to the graph of k at x equals 3. So what does it mean to write an equation for the line tangent to the graph of k at x equals 3? Can anyone try and explain it in words in the chat? If they can't, that's okay. So what are, or I guess broadly speaking, what are we doing in this question? Find a slope using the function, derivative at x equals 3. Interesting. Find derivative and use 1 point. Okay. So the way I would tackle on this question, and yeah, you're all pretty much right here, is first you have to find the derivative at x equals 3 and then plug it in to find the equation. So let's look at number A. So first we have to find the actual point, because we're basically creating a point slope form question. So what I would do is first I would find k of 3, and k of 3 is just f of g of 3. And so g of 3, if you go here, is 6. So that's equal to f of 6, which gives us 4. So we know that it's 3, 4. That's our point. Now to find our slope, or our derivative, we would do k prime of 3. So then in that instance, it would be what? What rule would we be using to find k prime of 3? What do we have to do? Chain, yes. So f prime of g of 3 times g prime of 3. And so then when we do f prime of 3, times f prime of g of 3 times g prime of 3. So first of all, g of 3, once again, is 6. So f prime of 6 times g prime of 3, f prime of 6 times g prime of 3. F prime of 6 is 5. And g prime of 3, I can't speak, g prime of 3 is 2. So we know that our slope is equal to 10. So then we just set it up. Sorry that I wrote diagonal here. A would look something like y minus 4 is equal to 10 times x minus 3. And this would be technically more correct. You can move the 4 over to the right side if you like. Yes. So this would be enough. And this is what I meant earlier when I said that you can leave answers unsimplified, because let's say you accidentally like distributed wrong and you got a wrong y equals mx plus b, then you would get the question marked wrong. Okay. So I'm going to erase all of this work for part A and we'll start on part B. So before I start on part B here, what does it mean? How exactly would we find h prime of 1? What would we need to do? Or what rule in calculus would apply here? All right, quotient rule. And you can either say like the little saying, it has to do with lows and highs and d's, or you can write it out algebraically. What's the way you remember the quotient rule? Low d high, high d low, and then low low, or low squared, whatever. Yeah, so the way I remember it, or the way I memorized it was, in this case, it would be g prime f minus f prime g all over f squared, if I'm correct there. So yeah, g prime low d high, high d low. Yeah, okay. So then we would basically plug in, we would put in 1 instead of like, it'd be g prime of 1 times f of 1. So g prime of 1 times f of 1 minus g of 1 times f prime of 1 all over f of 1 squared. And so I'm not going to bother doing all the algebra out. Can y'all plug it in the chat what you get as your answer in terms of this setup? So I got negative 1.5. How about everyone else? What are y'all getting? Same. I'm going to let some other people figure out their work. Take your time. Negative 1.5. Yeah. So it's negative 3 over 2, negative 1.5, and that would be the correct answer. So that's part B. And for BC folks, this question did not show up on the BC exam. In place of this, you got a lovely Taylor Maclaurin series. But then again, things are changing. You could see AB stuff on BC, not BC stuff on AB. But the test is changing. So let's look at part C now. It says evaluate the integral from 1 to 3 of the second derivative of f of 2x dx. So here, what would we be doing? What's the first thing we'd have to do? So I guess what we should start off with is what's the integral of the second derivative? It's what? Yeah, the derivative, or f prime, or the first derivative, etc., etc. So then what I would do is I would take 1/3 of f second derivative of 2x dx. So yeah, what would need to happen in order for us to be able to find this integral? We would have to, yeah, use chain rule. There we go. Sorry, I thought I saw it earlier. And so from there, we would have 1/2 times the first derivative of f of 2, the first derivative of 2x from 3 to 1. And so what would that end up giving us? 1/2 times what? So just apply f prime of 2x from 3 to 1. What would that look like? So that comes from the chain rule because of the 2x here. So whenever we find the integral of f to the second derivative of 2x, or yeah, you got to offset the 2. Okay, so I guess how that broadly works, it's u substitution, yeah. So if u is 2x, then it has to be 2dx, and so we put in a 2, we put in a 1/2, and then it works out. Sorry about that. Yeah, I was like, chain rules derivatives. Yeah, so u would be 2x, et cetera, et cetera. And so then our du would be 2dx, and so to put a 2 here, we have to put a 1/2 out here. Yeah. Sorry about that. So then now that we have 1/2 f prime of 2x from 1 to 3, that would look like 1/2 of f prime of what minus f prime of what? What would that give us? F prime of what minus f prime of what? F prime of, yep, 6 and 2. And so then calculate that and tell me what you get of 1/2 times f prime of 6 minus f prime of 2. Already got a quick answer here. 1. I would look, okay, well, let's look at it a little, yeah, 7 over, I was like, 1, not quite, because f prime of 6 is that a 5? Sorry about that. Oops, that's a 5. And then f prime of 3 is 7, so you get -2, or, oh wait, I did this math wrong myself too. It's 5 minus -2, which is +7. 7 times 1/2. Yeah, I was like, whoa. Then you get 7 over 2. Yeah. Yeah, happy April Fools, huh? I'm still confused about the 1/2. Do I just need more work with u substitution? Yeah, I would just work on u substitution. Not much else, yeah, to do with that, because the f prime of 2, or even like whenever we're finding, like, for instance, f of 2x, we're taking the integral. That doesn't work. We take the integral of f prime of 2 of x, then we would still have to offset it with, with a 1/2 at the front, because 2x, if u is equal to 2x, then in order to actually find the integral, we'd have to plug in a 2 and then put a 1/2 on the outside to offset. Yeah. There we go. All right, and so that's it for today at 57 minutes, checking out here. So I guess for next week, is there anything from the 2017 FRQ review that you want especially to focus on? BC kids, AB kids, y'all can all answer. What do you think you want more review on, I guess, is the question I'm asking. We can do slope fields again. Right, I see u substitution. That occasionally comes up. I'll hunt around for it. Oh, fundamental theorem of calculus, applications, velocity. I'm guessing that's for BC there. Taylor polynomial approximations, minimums. Okay, let me write all this down. Okay. Actually, I can just save the chat here. Okay, cool. I will touch on all these subjects specifically. And yeah, so we'll do the same thing. I'm going to try and keep it to like 15 minutes. And yeah, y'all are pretty funny with the whole curriculum. We're going to do 15, 20 minutes of BC, and then the rest will be AB. I'll just cut this stuff at the beginning about like updates to the exam. So yeah, I'm so excited to see y'all next week. Thank you all for coming, asking questions, keeping me accountable, and practicing calculus on a Monday in the afternoon. Like, that's crazy. Y'all are all going to do so great on the AP exam if you keep up the great work. And yeah, tune in to tonight's stream if you can at 9 p.m. Eastern. You'll get some great rules with L'Hopital, great practice with L'Hopital's rule in the afternoon with Megan Dwyer, one of our great calculus teachers. And yeah, I look forward to seeing y'all next week at 4 o'clock Eastern time here with me. Yeah, why are we? College Board actually printed it as La Hospital last year. Pretty funny. And I think that's, the old way that they used to write it was with an S. I'm not sure about that. I always called it L'Hopital's rule, though. All right. Well, thanks for joining me, everybody. Have fun operating on your limits. And yeah, I'll see you. We'll maybe see you this evening, or I'll see you next week. Bye.